we're going to solve this system of equations using the method of substitution. So we're going to pick one of these equations and solve for one of the variables. I think that the kind of obvious choice would be to solve for this x in the second equation, since we won't really end up with any fractions. So we end up getting that x is equal to 4 plus 3y. And this is going to be what we substitute into the first equation. So our first equation is 4x minus 5y is equal to 20. And where I see x, I'm going to instead substitute 4 plus 3y. So I've got 4, my x is equal to 4 plus 3y. Then I have minus 5y is equal to 20. Now I have an equation with one variable, which I can solve. So I distribute the 4 and get 16 plus 12y minus 5y equals 20. Combining like terms, I get 16 plus 7y is equal to 20. Subtracting 16 from both sides gives me 7y is equal to 4. And then finally dividing out by the 7, we get y is equal to 4/7. So this is going to be the y coordinate of our solution, or of the intersection point of the two lines. Then we're going to recycle this substitution that we used, x equals 4 plus 3y, and we're just going to plug in what we just found for y. So we have that x is equal to 4 plus 3y, and we know that y is 4/7. So we just go through and do order of operations. So we've got 4 plus, this gives us 12 over 7. 4 can be written as 28 over 7 plus 12 over 7. So we're getting common denominator. And then we can add across the top. So we end up getting 40 over 7 is our x. And so our solution is going to be at the coordinate 40 over 7, comma 4 over 7. So basically this means that if we were to graph these two lines, right, both of these, they're linear equations in two variables, they both form lines. We just found our intersection point. So this point right here is going to be at the coordinates 40 over 7, comma 4 over 7.